Question 5, write down the first even multiple of 7. So simply what we're going to do here is we're just going to list out the multiples of 7, and when we get to the first even number we stop. So 7 times 1 is 7, and then 7 times 2 is 14. Boom. 14 will be our answer here because that's the first even multiple of 7. So that's 14. So simplify 3 times 40. So here we've got two terms. We've got a number term, which is the 3 on its own, and then we've got a term, a t term. So what we're going to do here is just multiply out 3 by 4t. So 3 multiplied by 4t, which is 3 times 4 is 12. Since there's no other extra t term here, we just leave t as it is. So it's t here, so answer here is 12t. Simplify 8a minus 3a plus 2a. So 8a minus 3a, so that's 5a. And then add 2a, which will give you 7a. And simply your answer here is 7a. Question 7. Here's a probability scale. It shows the probability of each of the events A, B, C, and D. So as you can see on the probability scale that there's A, B, C, and D at various parts of the scale, showing various probabilities. We want to write down the letter of the event that is certain. So for probability to be certain, or an event to be certain, it means that the probability of it has to be 1. And if you just look at the diagram that we have here, we can see D has probability 1, which means D is the only event here that is certain to happen. Part B, we want to write down the letter of the event that is unlikely. So what we can do here is we can look at anything below half, because half means it's a 50-50% chance of happening. But for an event to be unlikely, it's got to have less than half probability to be unlikely. So then what we can do is we can also see that there's 2 entries here at A and B that we have, which probability of A happening is 0. Now the probability of something happening to be 0 means that it's impossible. So A is actually impossible here. So we will never be able to hit the event A. However, because we've got a B here and it's below half and it's close to 0 but not exactly, then that is something that matches the definition of an event being unlikely. So your answer here is B. So there's 12 counters in a bag, 3 are red, 1 is blue, 2 are yellow, and the rest of them are green. Caitlin takes a random counter from the bag. So we want to show the probability that this counter is yellow or green is 2 over 3. So what we can do, we can draw a probability tree. So mind the drawings here. Let's do that and that. So we have red, we'll have blue, yellow, and green. So we know that there's 3 out of 12 counters to be red. So we just pop that on. 3 out of 12. 1 of the counters are blue, so that's 1 over 12. 2 of the counters are yellow, so that's 2 over 12. Then it says the rest of the counters are green, so 3 red, 1 blue, 2 yellow, 3 plus 1 plus 2 is 6. That means that there's 6 unaccounted for at the moment, and that's the remainder. So that's green is 6 over 12. Now what we want to do is find a probability that it's yellow or green. So how do we calculate this? For this we will just work out the probability of picking a yellow, and the or symbolizes that we need to put a plus. So the probability of picking a green. I've just put a Y and G here to notify for the yellow or green. So we just plug the probabilities in. So we've got the probability of yellow here as 2 over 12, plus the probability of green here, which is 6 over 12. And that equals 6 plus 2 is 8 over 12. The denominators are the same, so we don't need to change them. Now, once we get to this point, we still haven't got the answer that we're looking for. So we can do a simplification here. So we can divide the top and bottom by 4, because that's the highest common factor between the two numbers. So if we divide top and bottom by 4, we get 2 over 3, and then we've got to the answer that we were looking for here. Question 6. 3 kg of meat costs £54. Nina buys 2 kg of the meat, so we want to work out how much Nina pays. The simple way to approach this is, we know that 3 kg costs 54. If we can work out how much 1 kg costs, then we can work out after 2 kg. So if we take this in steps, so we have 3 kg is 54. So we want to work out 1. So if we divide both sides by 3, we will get 1 equal to 54 over 3. 54 over 3, what we can do here is we can just do some long division. So we've got 54, 3. So first we check how many times can 3 go into 5. We know 3 can go into 5 once, and then there's a remainder of 2. So we do minus 3, because 3 multiplied 1 is 3. So that brings down the 2. We bring the 4 down for that we haven't used yet, so it's 24. So next we check how many 3's can go into 24. So how many 3's go into 24, and if you do quick maths, 3 multiplied by 8 gives you 24. So if we put an 8 up here, minus this 3 by 24, that gives a remainder of 0, so it means we're done with the division here. So this must mean we have 1 kg equals 18. Now, if we want to work out 2 kg, again, similar to what we were doing here to get to 1, so we want to multiply by 2 here. So similarly, we'll multiply by 2 here, and that will give us a total of 18 times 2, 36. And that's how much the meat for 2 kg will cost. Question 9. The centre of this circle is marked with a cross. So there's a cross in the middle of the circle. We want to write down the mathematical name for this line that's shown in the circle. So any point that is drawn from the middle of a circle to the circumference, and this is the circumference, the round around the circle. If we draw a point such as that or that, all these lines have the same name, and the name that they have is the radius. So we also want to know the mathematical name of a straight line that is touching the circle. Similar to the previous question, you can have as many lines as you like that are being drawn from corner to corner, such as this one. There's just one specific name for it. So any line that's touching a circle at one point is known as a tangent. Question 10. Tim and 3 friends go on holiday together for a week. The 4 friends will share the cost of the holiday equally. Here are the costs for the holiday. $12.80 for 4 return tickets, $640 for the villa, $220 for the car. Work out how much Tim has to pay. So simply what we can do here is, if you add up all the totals of the cost for this holiday, and then if you divide it by 4, because the cost of the holiday is being shared equally, you'll be able to get each friend's specific amount that they are going to pay, and in turn you'll work out how much Tim is going to pay. So if we just do a simple addition here, 640 and 220, so just adding across. 0 plus 0 plus 0 is 0, 8 plus 4 is 12, plus 2 is 14. Carry the 1 over because we can't write the 1 at the bottom yet. So 2 plus 6 plus 2 is 10, plus the 1 that we carried over is 11, and then carry 1 over because you can only put a 1 at the bottom here from the 11, and then 1 plus 1 is 2. So the total cost of the holiday, if no one was to split anything, would be 2,140. Now what we want to do is do some long division and see if we can calculate how much each person is paying. So similar to some previous questions, we see if 4 can go into 2. 4 is bigger than 2, so we know that it can't. So what you can do is just use 21. See how many times 4 goes into that. So 4 into 21 goes in 5 times. So if I write a 5 above the number 1, because we've used the second number in this division, so then minus 20 that gives us 1 here. We can bring the 4 down. So now we can look at 4 and 14. How many times 4 goes into 14? Well, that goes in 3 times, but it leaves a remainder of 2. So that's 12, because 4 times 3 is 12. And that will give us 2. If we bring this 0 over from the end, because that's the last figure remaining, bring that over, and then how many times does 4 go into 20? Well, 5 times. So you pop a 5 there. 5 times 4 is 20, and that leaves you with 0, and that's how you know you're at the end of the division. So your final answer here will be 535 is each person's cost for this holiday. Question 11, write down an example to show that each of the following 2 statements are not correct. So the first statement is factors of an even number are always even. So if we consider an even number, a double-digit even number, first one comes to my head is 12. So what are the factors of 12? So we have 3 and 4, and straight away you can see 1 is even, however this one is odd. So this is the number you can show that, say 3 is odd here. And part B, all the digits in odd numbers are odd. So again, if you consider an odd number, say 23, you can see that this one is odd, which is partially true here with this statement. However, you can see here 2 is even, so you can use the example of 23, or you can use any number that starts with an even number, ends in an odd, and that will disprove this statement here.